Alright, so welcome to my YouTube channel, and today I'm going to be discussing the synthesis of glycerophospholipids. Synthesis of glycerophospholipids. Now, before we synthesize the glycerophospholipids, first things first, you cannot synthesize what you don't know. So I would like us to look at the structure of glycerophospholipid before we synthesize the glycerophospholipid. Now, glycerophospholipid simply means the alcohol present in this phospholipid is glycerol. That is why it is called glycerophospholipid. Now, the first thing you have to note is how to draw the structure of glycerol. And glycerol is actually a 3-carbon compound. So glycerol has 1, 2, 3. So if you are drawing the structure of glycerol, this is it. This is it. Then all the 3 carbons have OH. So you have OH here, you have OH here, you have OH here. The next thing is just to balance up your hydrogen. So here we have H2, here H, here H2. So this is the structure of glycerol. Now glycerophospholipid. In glycerophospholipid, if I'm numbering this is my carbon 1, carbon 2, and carbon 3. Carbon 1 and 2 is always attached with fatty acid. So fatty acid is always on carbon 1, fatty acid is always on carbon 2. Then the phosphate group is on carbon 3. So my fatty acid is like this. So this is my fatty acid. Now if I turn it this way, you see that I'll have something like this. Right? I'll have something like this. I didn't change anything, I just flipped it. So now I'm going to draw it close. So I'll be having something like this. Now this is the fatty acid, this is alcohol from the glycerol. There will be a condensation reaction in that H will condense with OH. Water is formed out. So this thing is going out as water. And here, this bond joins to this. Same thing is happening on carbon 2. Let me use arrow 1 and arrow 2 to differentiate the fatty acids. So now this structure we have on the board is diacylglycerol. If I attach only one fatty acid group, it's called monoacylglycerol. If I attach 2, it's called diacylglycerol. If I attach 3, it becomes triacylglycerol. But that's not what we're interested in. What we want to look at is glycerophospholipid. Now, after attaching fatty acid on carbon 1 and 2, the next thing is carbon 3, you attach a phosphate group, phosphoric acid. So this is phosphoric acid, you've attached this. So what you have here now is your glycerophospholipid. But this is the simplest form of glycerophospholipid. This is the simplest form because you have hydrogen attached. But in other cases, you can have, if you have just something like this is your phosphatidic acid. Phosphatidic acid. But in other glycerophospholipids, we always have a head group attached. So we can have a head group attached here. The head group can either be serine. If the head group is serine, we call it phosphatidylserine. If the head group here is choline, you call it phosphatidylcholine. If the head group is ethanolamine, you call it phosphatidylethanolamine. If it is inositol, you call it phosphatidylinositol, just like that. So we have head group attached here. Now, so basically, this is how a glycerophospholipid is. Now, we want to look at the synthesis of glycerophospholipid. How do we synthesize glycerophospholipid? That's what we are going to look at now. So we are going to take it step by step. Alright, so we'll be looking at the synthesis of glycerophospholipids. We've seen the structure of glycerophospholipid. So this is actually a simplified diagram. Please, I must say there are different pathways for the synthesis of glycerophospholipid. You must not start from glycerol. But I'm going to use this pathway, this simplified pathway. So in exam, you can actually use this pathway I'm using. But listen to the end. Alright, now we are starting from glycerol. Recall, let me put what we have here so that you can be visualizing what we are synthesizing. Alright, so this is what we want to synthesize. This is a glycerophospholipid. Remember, this is glycerol. This is an acyl group, that is fatty acid. This is another acyl group, fatty acid. We have phosphate, then the head group. The head group is always attached to the phosphate. Now, we are starting from glycerol. Then the first step is activation of glycerol, phosphorylation of glycerol. ATP comes in and leaves as ADP. If ATP is coming in and leaving as ADP, you agree with me that it is only one phosphate group we are taking from this. So the one phosphate group is attached to carbon 3 of glycerol. So if we have the structure of glycerol here, this is the structure of glycerol. Once ATP comes in and donates one phosphate group, the phosphate group goes to this position 3 here and attached. So what we are now having is glycerol 3 phosphate, because this is glycerol and the phosphate group is on carbon 3. So we now have glycerol 3 phosphate. Now, after getting the glycerol 3 phosphate, now ask yourself, what is remaining to make this thing glycerophospholipid? I think we need to add a fatty acid group here on carbon 1. We need to add another fatty acid group on carbon 1. So you see the importance of visualizing what you are doing. Phosphate group have been attached by ATP. Now we want to add fatty acid at carbon 1 and fatty acid at carbon 2. So here we have our activated fatty acid called fatty acyl-CoA, or you just call it acyl-CoA. Now the fatty acyl-CoA comes in and CoA is given up. So the acyl group is now added to carbon 1. The enzyme catalyzing that is acyl transferase. So acyl transferase transfers acyl group from fatty acyl-CoA to position 1 of this glycerol. So we'll now be having 1 acyl glycerol 3 phosphate. So here I'll be attaching my acyl group here. So when you use fatty acid as you're attaching something from fatty acid, you call it acyl group. So this is 1 acyl group attached. Now we still need to attach another acyl group here, right? So please, this 1 acyl glycerol 3 phosphate is also called lysophosphatidate or lysophosphatidic acid. Then we attach the next fatty acid. The next fatty acid is attached. That's why we are bringing our acyl-CoA again, and CoA is leaving. The enzyme catalyzing that reaction is acyl transferase. So this time the fatty acid is attached on position 2. So we now have 1,2-diacyl glycerol 3 phosphate. 1,2 because we have one acyl group is here, another acyl group is on 2. So we have 1,2-diacyl glycerol 3 phosphate. Now this 1,2-diacyl glycerol 3 phosphate, we can actually at this point here, from here, the reaction can take diverse pathways. From this 1,2-diacyl glycerol 3 phosphate, from here we can remove the phosphate group, this phosphate group on position 3, or we decide to add our head group directly. So from here, you know, if you add serine here, if you add serine directly to this phosphate group from here, what you are having is phosphatidic serine already. So if you add choline, what you are having is phosphatidic choline and the rest. So you can actually add from here. But if you want to go on, you can actually remove this phosphate group first. If you remove this phosphate group first, which is this pathway, phosphohydrolase will remove this phosphate group here. So if this phosphate group is removed, what we now have is 1,2-diacyl glycerol. We've removed the phosphate. Now, you know, if you want to synthesize our glycerophospholipid, anything we want to add here, we must attach phosphate before the head group. Alright, so here I just simplified this part. Phosphorylated head group is attached. But I want to explain more here now. If we want to synthesize phosphatidylcholine, first of all, if you want to synthesize phosphatidylcholine, you know that the phosphate will be here and choline will be attached, right? Choline will be attached. Now, The stuff here is, for now, we've removed this sausage group. So if choline is coming in, it must be coming in as phosphocholine. That is, choline attached to phosphate so that it can attach this position. So choline, if choline is coming in, we can have something like this. From choline, we can activate choline with ATP, and ADP is going off to form phosphocholine. Phosphocholine. You can actually attach this phosphocholine directly to 1,2-diacylglycerol to form your phosphatidylcholine, or this one can actually undergo, if CTP comes in, CTP is cytidine triphosphate. If it's coming in, we can have what we call CDP choline. CDP choline. Now, pi is going out. So CDP choline is actually the form mostly used. If CDP choline comes now, CDP choline can attack this position, can attack here, and in the process, CMP is giving off. CMP is giving off. So what is still attached? If CMP is giving off, what is still left here is phosphocholine. So it is still phosphocholine we are attaching to this diacylglycerol to get our phosphatidylcholine. So basically, if you want to attach your choline here, what you're attaching is phosphocholine. So if you attach phosphocholine here, what you'll be getting as your glycerophospholipid is phosphatidylcholine. If you attach phosphoserine here, what you'll be having is phosphatidylserine. If you attach phosphoethanolamine, what you'll be having is phosphatidylethanolamine. And it goes on like that. So in exam condition, if you are asked to synthesize a specific glycerophospholipid, please don't just make it general this way. Use a specific head group. Let me take, for example, if I have something like this. If I want to attach serine, you all know serine is an amino acid, H. This is the structure of serine. This is the structure of serine. Now, if I want to attach serine, and I already have my diacylglycerol, okay, let me use this phosphatidate. If I want to attach serine, serine is attached at the OH group. So OH will take one H here to form water. So we are left with one hydrogen. Next here is CH2. Next here is CH. Next, this CH, now NH2 is attached to it, and COOH is still attached to it. This stuff we have on the board here, this is phosphatidylserine. Phosphatidylserine. If you decarboxylate phosphatidylserine, that is, if you remove this carboxylic acid group, what you are having left is called ethanolamine. Ethanolamine is like this. Ethanol is CH3, CH2OH. Ethanolamine, meaning add an amino group. So we have this. So this is ethanolamine. If you are attaching OH, that's this formation, we have this, and we have this. So if you decarboxylate phosphatidylserine, you have phosphatidylethanolamine. So from phosphatidylethanolamine now, if you want to form phosphatidylcholine, you know phosphatidylethanolamine can still be written like this. If I write NH3 plus, I've not changed anything. If I replace all these three hydrogen in phosphatidylethanolamine with CH3, that is, if I have this CH3, 3 of it, what can I have is phosphatidylcholine. So the bottom line of what I'm saying is, once you get to this point, 1,2-diacylglycerol, you can be adding your phospho. If you are not drawing the structure from here, if you want to synthesize, phosphatidylserine, you can just come here. To keep things simple, you can just come here and write phosphoserine. phosphoserine. Then here you write phosphatidylserine, just like that, to keep things simple. All right, but if you forget anything I've said so far, the bottom line is from glycerol you phosphorylate it to glycerol 3-phosphate, then you add fatty acid on position 1 and 2. That was what you did here. From here 1,2-diacylglycerol 3-phosphate, you can just be adding your head group, or you decide to remove the phosphate group on position 3 to have 1,2-diacylglycerol. Now if you've gotten 1,2-diacylglycerol, all you'll be adding is phospho head group, the phosphorylated head group. But if you are adding from here, what you are adding, since phosphate is already there, what you are adding is just what? Just the head group. Either serine, choline, ethanolamine, just the head group, because the phosphate is already on position 3. The phosphate is already here, it's just to be adding the head group. But if you remove this phosphate, like in this case 1,2-diacylglycerol, no phosphate, then what you'll be adding to this is the phosphorylated head group, the head group carrying phosphate. Any of them you do, you are correct. You are correct. So basically, this is actually a simplified version of the synthesis of glycerophospholipid.